Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 4 units. Side CD of quadrilateral ABCD equals to 2 units. We also know that BC equals to AD, and angle DAB, this angle equals to 30 degrees. Angle ABC, this angle equals to 90 degrees. And we want to find out the area of this quadrilateral ABCD. So first of all, we will do a construction. From point D we will draw perpendicular to side AB. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point between the perpendicular from point D and AB as point E. And we also will define line segment DE as A. That is to say, line segment DE equals to A units in its length. And we will focus on the right triangle ADE. In the right triangle ADE, sine of 30 degrees equals to DE over AD. I will write it down. In the right triangle ADE, sine of 30 degrees equals to DE over AD. And we know that sine of 30 degrees is 1 over 2, and DE equals to A according to our definition, so we will substitute DE by A, and you will get that it's actually DE is A over AD. So here we will cross multiply this equation number 1, and we will get that AD equals to 2 times A. So we found out that AD equals to 2A. So we can write here that AD equals to 2A. And because of the fact that AD equals to CB, we know that AD equals to CB. It is given us in the question that AD equals to CB from one side, but from the other side we found out that AD equals to 2A. So from this equation we will derive that CB also equals to 2A. CB equals to 2A. So we can write here that CB equals to 2A. CB equals to 2A. 2A. In the next step, we will, from point D, we will draw perpendicular to CB. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point between the perpendicular from point D to CB as point F. In the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. I will repeat on rule number 1 again. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So actually, according to rule number 1, the sum of the angles in this quadrilateral DFEB must be equal to 360 degrees. In this quadrilateral DFEB, we have 3 right angles, 1, 2, 3. The sum of 3 right angles is 270 degrees, plus the size of this angle that we will define as angle X. So the sum of those 4 angles must be equal to 360 degrees according to rule number 1. So here we will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees. It is actually 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees, so we can substitute angle X by a right angle. So you can see that all angles inside quadrilateral DFEB are right angles, and we also have rule number 2. According to rule number 2, Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So if not a square, it must be a rectangle. So I will read rule number 2 again. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So because of the fact that quadrilateral DFEB, this quadrilateral has 4 right angles, we will relate to quadrilateral DFEB as a rectangle. Okay? According to rule number 2, quadrilateral DFEB is a rectangle. Okay, I'll repeat again. Quadrilateral DFEB is a rectangle according to rule number 2. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. I repeat again on rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle DFEB are equal to each other. It means that DE equals to FB. DE equals to FB. Repeat again, in the rectangle DFEB, according to rule number 3, DE equals to FB, but according to our definition, DE equals to A, so we can write down that DE equals to A, and from this equation we will derive that FB also equals to A. So we can write here that FB equals to A, And what is the value of CF from the drawing? It is very easy to see that CF equals to CB minus FB. CB minus FB equals to CF. So CF equals to CB is equal to 2A, and FB equals to A. So CF equals to 2A minus A is A. So we found out that CF equals to A. So we can write here that CF equals to A. In the next step, we will join together points D and B by a straight line. And we will prove that triangle DFB is congruent to triangle DFC. I'll repeat again. We will prove that triangle DFB is congruent to triangle DFC. So why those two triangles congruent to each other? First of all, we know that BF equals to FC equals to A. BF equals to FC equals to A. Okay. BF equals to FC equals to A. We also know that those two angles are equal to each other, they are both right angles, so angle DFB equals to angle DFC, this angle, and both angles are right angles, that is to say they are equal to 90 degrees. I'll repeat again. Angle DFB equals to angle DFC equals to 90 degrees. And DF is a common side, it belongs to both triangles, so DF equals to itself. DF equals to DF is a common side that belongs to both triangles. I'll repeat again. DF equals to DF is a common side that belongs to both triangles. So we actually proved that this triangle DFB, congruent, this is the sign of congruent to triangle DFC, according to side angle side rule. I'll repeat again. We proved that triangle DFB can go into triangle DFC according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between them in one triangle congruent to two sides and the angle that is located between them in the other triangle, then you proved that those two triangles can go into each other according to side against side rule, and we actually proved that those two sides and this angle that is located between them in triangle DFB can go into those two sides, and the angle that is located between those two sides, that is to say this angle, in triangle DFC. Therefore we proved that those two triangles can go into each other according to side against side rule. And from the fact that those two triangles can go into each other, we will conclude that DC equals to DB. DC equals to DB. Again, DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. But we know that DC equals to 2 units. It is given us in the question. So we can write down that DC equals to 2 units. And from this equation, we will derive that DB also equals to 2 units. DB equals to 2 units. In the next step, I will present to you a new law, and we will implement the new law in triangle ADB. So actually the law, it is actually the law of cosines. And the law of cosines is true in any triangle. So you can write down that in any triangle, so if we have triangle ABC, that could be any triangle. This is triangle ABC. And we know that side AB of triangle ABC equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units. And the angle between side AB and side BC is angle theta. Then, according to the law of cosines, A squared plus B squared minus 2 times AB will be equal to C squared. Okay, so in any triangle, A squared plus B squared minus 2 times AB cosine theta, actually 2 times AB cosine theta. I'll write it again. A squared plus B squared minus 2 times AB cosine theta equals to C squared. I'll repeat again. A squared plus B squared minus 2 times AB cosine theta equals to C squared. So here we will subtract C squared from this equation, and we will also add 2AB cosine theta to this equation, and we will get that A squared plus B squared minus C squared equals to 2 times AB cosine theta. Here we will divide this equation by 2 times AB, and we'll get that cosine theta equals to a square plus b square minus c square over 2 times ab So in any triangle, cosine theta equals to a square plus b square minus c square over 2 times ab. And we can implement the law of cosines in our triangle ADB. So I will copy this triangle ADB in a new page, and we will implement the law of cosines in this triangle ADB. Okay? So this is actually triangle ADB. AD equals to 2A, AB equals to 4 units, DB equals to 2 units, and the angle DAB equals to 30 degrees. So we will implement the law of cosines from this triangle DAB, according to the law of cosines, cosine 30 degrees equals to 2a square plus 4 square minus 2 square over 2 times 2a times 2, 2 times 2a times 4. So here we know that cosine 30 degrees equals to square root of 3 over 2, and it equals to 2a square is 4a square, plus 4 square is 16, minus 2 square is minus 4, over 2 times 4 is 8, 8 times 2a is 16a. Here 16 minus 4 is 12, so I'll write it down. It will be equal to 4a squared plus 12 over 16a. Here we will multiply this equation by 16, and we'll get that is actually 16a. Square root of 3 over 2 times 16 times a equals to 4a squared plus 12. 16 over 2 is 8. So we get that square root of 3 times 8a equals to 4a squared plus 12. Here we will divide this equation by 4, and we will get that 8 over 4 is 2, so 2 times square root of 3 times a equals to 4 over 4 is 1, so here we will have a squared plus 12 over 4 is 3. Here we subtract 2 times square root of 3a from this equation, and we will get that a squared plus 3 minus 2 times square root of 3 times a equals to 0. Here we will substitute 3 by square root of 3 squared, because square root of 3 squared equals to 3. We will get that a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. So actually this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific equation, a equals to a and b equals to the square root of 3 units. So a minus b squared that equals to 0 will be equal to a minus square root of 3 squared that equals to 0. We take out of this equation and we get that a minus square root of 3 equals to 0 because of the fact that the square root of 0 is 0. Here we will add square root of 3 to this equation and we will get that a equals to square root of 3 units. So here we found out that a equals to square root of 3 units. Here also a equals to square root of 3 units. And here also a equals to square root of 3 units. Okay. Now we will focus on the right triangle, triangle DEB, this right triangle. And we will implement the Pythagoras theorem on this right triangle, triangle DEB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, DE squared plus EB squared equals to DB squared I'll repeat again. If we focus on the right triangle, triangle DEB, according to the Pythagoras theorem, PT is the abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is dB square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to DE square plus EB square. So DE equals to square root of 3 units. So DE square is square root of 3 squared, that is 3, plus EB is the missing variable, so we will leave it as it is, plus EB square equals to DB square. DB equals to 2, so DB square is 2 squared, 2 squared is 4. So in conclusion, we found out that 3 plus EB square equals to 4. Here we will subtract 3 from this equation, equation number 1, and we will get that EB square equals to 4 minus 3 is 1. Here we will take a root out of this equation, equation number 1, and we will get that the square root of that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1 unit. So here EB equals to 1 unit, and because of the fact that the opposite sides of a rectangle are equal to each other, DF also will be equal to 1 unit. And what is the value of AE? The value of AE, it is actually equals to AB minus EB. AB minus EB equals to AE. I'll repeat again. AE equals to AB minus EB. So AE equals to AB. AB is 4 units minus EB. EB is 1 unit. So AE equals to 4 minus 1, that is to say AE equals to 3 units. So we found out that AE equals to 3 units. AE equals to 3 units. Now it is very easy to find out the area of quadrilateral ABCD because of the fact that the area of quadrilateral ABCD actually the squared brackets here is the sign for the area. It means the area of quadrilateral ABCD will be equal to the area of triangle ADE, the right triangle ADE, plus the area of rectangle DFEB, plus the area of the right triangle DCF. I'll repeat again. The area of quadrilateral ABCD will be equal to the area of triangle ADE plus the area of rectangle DFEB plus the area of the right triangle DCF. And the area of triangle ADB equals to the base of the triangle, that is actually AE, times the I to the base, that is actually DE, over 2. So we found out that the area of triangle ADE equals to AE times DE over 2, and the area of rectangle DFEB, this rectangle, will be equal to the width of the rectangle that is actually EB times the length of the rectangle that is actually DE. Okay, the area of rectangle DFEB is the width of the rectangle that is AE times the length of the rectangle that is DE, all divided by 2. No, here it is the width of the rectangle that is EB times the length of the rectangle that is DE, so it is the width times the length. Okay, and the area of the right triangle DCF equals to the area, the base of the triangle that is actually AE times the height to the base that is actually DE over 2. So the area of triangle ADE equals to AE is 3 units, times DE is equal to 3 units here, over 2. So we found out that the area of triangle ADE equals to 3 times equal to 3 units over 2. Plus the area of rectangle DFEB, the area of rectangle DFEB equals to EB is 1 times DE it is equal to 3 units. So we found out that the area of rectangle DFEB is equal to 3 units plus the area of triangle DCF that is actually AE it is actually the area of triangle DCF, it is actually DF times CF. I repeat again, the area of triangle DCF is DC times, it is actually DF, that is the base of the triangle, times the height, that is CF over 2. So it is DF times CF over 2. So DF is equal to 1 unit, CF equals to square root of 3 units, all divided by 2. So we found out the area of the 3 figures. Here we will multiply square root of 3 by 2 and then we will divide it by 2 in order to have a common factor with the other 2 expressions. And then here we will take out a common factor of square root of 3 over 2 out of these 3 expressions. So what is left from this expression after we took the common factor of square root of 3 over 2, what is left? It is actually 3. And what is left from this expression after we took from it square root of 3 over 2 is a common factor? What is left is that it is actually 2. And what is left from this expression after we took the common factor from it? What is left is it is actually 1. So we got the square root of 3 over 2 times 6. So it is 6 times square root of 3 over 2. 6 over 2 is 3. So in conclusion, we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. I will repeat again. We found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this quadrilateral ABCD according to the second method. In the second method, we will do another construction. From point A, we will draw perpendicular to AB. So this angle will be a right angle, it will be equal to 90 degrees. And from point C, we will draw perpendicular to CB. So this angle will be a right angle, that is to say it will be equal to 90 degrees. And we'll define the intersection point between the perpendicular from point A and the perpendicular from point C as point E. So actually here, in quadrilateral ABCE, we have 3 right angles, 1, 2, 3. And the sum of 3 right angles is 270 degrees. Plus the size of the fourth angle that we will define as angle X. So the sum of those 4 angles must be equal to 360 degrees according to rule number 1. I'll repeat again. In quadrilateral ABCE, the sum of the angles must be equal to 360 degrees according to rule number 1. That is to say, it has 3 angles that equals to 90 degrees. Therefore, the sum of those 3 angles is 270 degrees plus the size of the fourth angle, that is actually angle X, must be equal to 360 degrees according to rule number 1. So here we will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees. That is to say, angle X equals to 90 degrees. So we can write here that angle X is a right angle. It equals to 90 degrees. So you can see from the drawing that all four angles inside quadrilateral ABCE are right angles, and we also have rule number 2 that any quadrilateral that has four right angles must be at least a rectangle, so we will relate to quadrilateral ABCE is a rectangle according to rule number 2. And we also have rule number 3 that says that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to EC according to rule number 3. Again, AB equals to CE according to rule number 3, that the opposite sides of a rectangle are equal to each other, but it is given us the question that AB equals to 4 units, and from this equation we will derive that CE also equals to 4 units. CE equals to 4 units, so we can write here that CE equals to 4 units. Likewise, CB equals to AE according to rule number 3. And if we define angle CB as x, that is to say angle CB equals to x according to our definition, then from this equation we will derive that AE also equals to x. But it is given us in the question that CB equals to AD. CB equals to AD. And and CB equals to x according to our definition. So from this equation we will derive that AD also equals to x. Okay, AD equals to x. Here AD equals to x. So in the next step we will join points E and D together by a straight line. And we will join points D and B together by a straight line. What is the value of angle DAE? What is the value of this angle? The value of this angle, it equals to 90 degrees minus 30 degrees. Again, 90 degrees, that is this angle, minus 30 degrees, that is this angle, equals to this angle, that is actually 60 degrees. So we found out that angle DAE equals to 60 degrees. So I will copy triangle AED in a new page and we will analyze it. Okay. We know that AE equals to ED equals to X. Angle DAE, this angle equals to 60 degrees. So I copied triangle AED in a new page, and we know that AE equals to AD, and we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, in front of these two sides there must be also equal angles. That is to say, those two angles must be equal to each other because they are located in front of the equal sides. So if we define this angle as y, then this angle will be also equal to y. And we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle AD, the sum of the angles is equal to 180 degrees. That is to say, angle y plus angle y plus this angle that is 60 degrees. In total, they must be equal to 180 degrees. Y plus y is 2y, 2y plus 60 degrees equals to 180 degrees. Here we will substitute from this equation 60 degrees, and we got the 2y equals to 180 degrees, 120 degrees. Y equals to 120 degrees. We divide this equation by 2 and we get that angle y equals to 120 degrees over 2 is 60 degrees. So we found out that this angle equals to 60 degrees, and this angle that is actually angle y also equals to 60 degrees. So actually we found out that triangle AED is an equilateral triangle. That is to say, all of its sides are equal to each other. So if AE is x and AD is x, then ED also must be equal to x. And here, so we know that ED equals to x, this angle equals to 60 degrees, and this angle also equals to 60 degrees. But what is the value of this angle? Angle DEC. Angle DEC equals to 90 degrees minus 60 degrees. Okay? Angle AEC equals to 90 degrees, angle AED equals to 60 degrees. So if we subtract 60 degrees from the right angle, we will get the value of this angle, that is will be equal to 90 degrees minus 60 degrees, so this angle equals to 30 degrees. In the next step, we'll prove that those two triangles can go into each other. So I write it down. We'll prove that triangle ADB, this triangle, congruent to this triangle, triangle DEC. I'll repeat again. We will prove the triangle ADB congruent to triangle DEC. So, why those two triangles congruent to each other? First of all, we know that AB equals to EC equals to 4 units. I repeat again. We know that AB equals to EC equals to 4 units. We also know that those two angles they are equal to each other, they are both equal to 30 degrees, so angle DAB equals to angle DEC, this angle, and they are both equal to 30 degrees. I'll repeat again. Angle DAB equals to angle DEC equals to 30 degrees. And AD equals to ED equals to X. AD equals to ED equals to X. So repeat again. AD equals to ED equals to X. So we actually proved that this triangle ADB congruent to this triangle EDC so triangle ADB congruent to triangle EDC according to side angle side rule. Actually, those two sides and the angle that is located between those two sides, that is to say this angle, in triangle ADB congruent to those two sides and the angle that is located between those two sides in triangle ADC, therefore those two triangles congruent to each other according to side angle side rule, and from the fact that those two triangles congruent to each other, we will conclude that CD equals to DB. CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. So CD equals to DB. But it is given us in the question that CD equals to 2 units. CD equals to 2 units. So from this equation, 2 equals to CD equals to DB, we will derive that DB also equals to 2 units. DB also equals to 2 units. In the next step, we will implement the law of cosines on this triangle ADB. So I will copy triangle ADB in a new page and we will implement the law of cosines in this triangle ADB. So I copied triangle ADB this new page, and we will implement the law of cosines in this triangle ADB. According to the law of cosines, cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4 . We know that cosine 30 degrees is square root of 3 over 2. And it equals to x squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, over 2 times 4 is 8, 8 times x is 8x. So here we will multiply this equation by 8x, and we will get that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4, so we get that 4 times square root of 3x equals to x squared plus 12. Here we subtract 4 times square root of x from this equation, and we will get that x squared plus 12 minus 4 times square root of 3x equals to 0. So here we will substitute 12 by 2 times square root of 3 squared, because 12 equals to 2 times square root of 3 squared, and we will get that x squared plus 2 times square root of 3 squared, that equals to 12, minus, we will substitute 4 by 2 times 2, so x squared plus 2 times square root of 3 squared, that is 12, minus, we will substitute 4 by 2 times 2, so we get that 2 times x times 2 times square root of 3 equals to 0. Actually, this equation is very similar to the trigonometric identity that x squared and that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, we know that a equals to x, b equals to 2 times square root of 3. So so we can substitute our specific expression by a minus b squared. In our specific expression, a minus b squared will be equal to a is x, minus b is minus 2 times square root of 3, a squared, that equals to 0. Here we will take a root out of this equation, and we will get that x minus 2 times square root of 3 equals to 0. Here we will add 2 times square root of 3 to this equation, and we will get that x equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units. X equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units. Okay, now in order to calculate, actually the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. And in order to calculate the area of triangle ADB, we will draw a perpendicular from point D to AB. We will define the touching point between the perpendicular from point D to AB as point S. We will define the line segment SD as H. So in triangle ADB, sinus 30 degrees equals to H over 2 times square root of 3 . We will multiply equation number 1 by, first of all, sinus 40 degrees is 1 over 2. So 1 over 2 equals to H over 2 times square root of 3. Here we will multiply equation number 1 by 2 times square root of 3, and we will get that H equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we found out that H equals to square root of 3 units. Now it is very easy to find out the area of triangle ADB. The area of triangle ADB will be equal to the base of the triangle, that is actually AB, times the height, that is H over 2. So found out that the area of triangle ADB equals to the base of the triangle, that is AB, times the height, that is H over 2. AB is 4, H is square root of 3 over 2, so 4 over 2 is 2. So we found out that the area of triangle ADB equals to 2 times square root of 3 square units. Again, the area of triangle ADB equals to 2 times square root of 3 units. And the only thing that is left to find is to find out the area of triangle DBC, because we know that the area of triangle DBC plus the area of triangle ADB equals to the area of quadrilateral ABCD that we are looking for. So we found out the area of this triangle DBC. We will define this side as A, this side as B, this side as C. The semi-perimeter of triangle DBC, this triangle, will be equal to the perimeter over 2. The perimeter over 2 of any triangle is equal to the semi-perimeter of the triangle. So A plus B plus C over 2 is the semi-perimeter of triangle DBC. So, and S is the abbreviation for the semi-perimeter. So S of triangle DBC will be equal to A is 2, B is 2, and C is 2 times square root of 3 units over 2. So the semi-perimeter of triangle DBC equals to 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2, 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle DBC S equals to 2 plus square root of 3 units, and the area of triangle DBC will be equal to the square root of S times S minus A times S minus B times S minus C. We know that S equals to 2 plus square root of 3 units, A equals to 2 units, B equals to 2 units, and C equals to 2 times square root of 3 units. So we can put the data inside this equation for the area, and we will find out the area of triangle DBC. The area will be equal to S is 2 times 2 plus square root of 3, the semi-perimeter of triangle DBC, 2 plus square root of 3 units, times S minus A. S is 2 plus square root of 3, minus A is 2, so 2 minus 2 is 0, so we left only square root of 3. S minus B is the same as S minus A because A equals to B, so it is also square root of 3. And S minus C is 2 plus square root of 3 minus 2 times square root of 3. That is actually 2 minus square root of 3. Here, square root of 3 times square root of 3 is 3. And 2 plus square root of 3 times 2 minus square root of 3. We will calculate the value of this expression according to the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. Here A is 2, so A squared is 2 squared is 4, and B is square root of 3, so B squared is square root of 3 squared, that is 3, so it is 4 minus 3. 4 minus 3 is 1, 1 times 3 is 3, so we found out that the area of triangle DBC equals to square root of 3 square units, and the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DBC. We have already found out that the area of triangle ADB is 2 times square root of 3 units, and we just right now found that the area of triangle DBC equals to square root of 3 square units. So 2 times square root of 3 units plus 1 times square root of 3 units is 3 times square root of 3 square units. So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, exactly as we found in the first method. So now I'll summarize the lecture. Actually, we wanted to find out the area of quadrilateral ABCD in the first method. We did a construction from point D. We do perpendicular to AB, so this angle is 90 degrees and this angle is 90 degrees. We defined the touching point between the perpendicular from D to AB as point E. We defined line segment DE as A, and we focused on triangle AED, the right triangle AED. In this right triangle, we know that sine 30 degrees equals to DE over AD. In triangle A, the right triangle ADE, sine 30 degrees equals to DE over AD. Sine 30 degrees is 1 over 2. DE is A according to our definition. So we got that 1 over 2 equals to A over AD. We cross multiply this equation number 1, and we found out that AD equals to 2A. So here AD equals to 2A. But it is given us in the question that AD equals to CB. And we just right now found out that AD equals also to 2A. So from this equation we will derive that CB also equals to 2A. So here CB equals to 2A. Then I presented to you rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. Here we drew perpendicular from point D to CB, so this angle is 90 degrees and this angle is 90 degrees, and we define the touching point between the perpendicular from point D and CB as point F. Then I presented to you rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So if we focus on quadrilateral DFEB, the sum of its angles must be equal to 360 degrees according to rule number 1. Quadrilateral DFEB has 3 right angles, 1, 2, 3. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is angle X. The sum of those four angles must be equal to 360 degrees according to rule number 1. That is to say 270 degrees plus angle X must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation, and we got that angle X equals to 90 degrees. So angle X is a right angle, therefore all angles inside quadrilateral DFEB are right angles. And we have rule number 2 that any quadrilateral that has 4 right angles must be at least a rectangle. Therefore, and because of the fact that quadrilateral DFEB has 4 right angles, we will relate to quadrilateral DFEB as a rectangle. Then I presented to you also rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, DE equals to FB. According to rule number 3, DE equals to FB, but DE equals to A according to our definition. From this equation we will derive that FB also equals to A. So here FB also equals to A. So if FB equals to A and CB equals to 2A, what will be the value of CF? CF equals to CB minus FB. CF equals to CB minus FB. That is to say CF equals to CB is 2A and FB is A. So CF equals to 2A minus A. That is to say CF equals to A. CF equals to A. In the next step we will connect together points D and B together by, we connected points D and B by straight line, and we proved that those two triangles can go into each other. The triangle DFB can go into triangle DFC. Why those triangles can go into each other? First of all, we know that BF equals to FC equals to A. BF equals to FC equals to A. We also know that angle DFB equals to angle DFC equals to 90 degrees. Those two angles are right angles, they are both equal to 90 degrees. And DF equals to DF, it is a common side that belongs to both triangles. So we actually proved the triangle DFC, the triangle DFB can go into triangle DFC according to side against side rule. Okay, when you have two sides and the angle between them in one triangle can go into two sides and the angle between them in another triangle, then those two triangles can go into each other according to the angle side rule. And we have those two sides and the angle between them in triangle DFC can go into those two sides and the angle between them in triangle DFB. Therefore, those two triangles can go into each other according to side angle side rule. And from that fact that those two triangles can go into each other, we will conclude that DC equals to dB. DC equals to dB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say CD and dB, will be equal to each other. Okay, so DC equals to dB, but it is given us in the question that DC equals to 2 units. And from this equation we will derive that BD also equals to 2 units. Here BD equals to 2 units. Okay. In the next step I presented to you the law of cosines that is true in any triangle. If side AB equals to A units, side AC equals to C units, and side BC equals to B units, and the angle between AB and BC is angle theta, then A square plus B square minus 2 times AB times cosine theta will be equal to C square. It is true in any triangle. Here we subtracted C square and added to 2 times AB cosine theta to this equation, and we got that A square plus B square minus C square equals to 2 times AB cosine theta. Here we divided this equation by 2 times AB, and we got that cosine theta equals to A square plus B square minus C square over 2 times AB, and this equation is true in any triangle. We implemented this law, the law of cosines, in triangle ADB. So I copied again this triangle ADB in a new page, and we implemented the law of cosines in this triangle ADB. This is triangle ADB. AD equals to 2A, DB equals to 2, AB equals to 4, and angle AB equals to 30 degrees. So according to the law of cosines, cosine 30 degrees equals to 2A square plus 4 square minus 2 square over 2 times 2A times 4. Here we know that cosine 30 degrees equals to square root of 3 over 2. 2A square is 4A square, 4 square is 16, minus 2 square is minus 4, 16 minus 4 is 12. And 2 times 4 is 8, 8 times 2A is 16A. So in the denominator we have 16A, and in the numerator we have 4A square plus 12, because 16 minus 4 is 12. Then we multiply this equation by 16A, and we got that square root of 3 over 2 times 16A equals to 4A square plus 12. 16 over 2 is 8, so in this side of the equation we have square root of 3 times 8 times A equals to 12 plus 4A square. Here we divided this equation by 4, and we got that 8 over 4 is 2, so in this side of the equation we have 2 times square root of 3 times A, and 4A square over 4 is A square, 12 over 4 is 3, so we got the 2 times square root of 3 times A equals to A square plus 3. Here we subtract the 2 times square root of 3A from this equation, and we got that A square plus 3 minus 2 times square root of 3A equals to 0. Here we substituted 3 by square root of 3 square, because 3 equals to square root of 3 square, and we got that A square plus plus A square plus square root of 3 square plus 2 times A times square root of 3 equals to 0. This expression is very similar to the algebraic identity that states that A square plus B square minus 2 times AB equals to A minus B square, that equals to 0. So we can substitute our expression by A minus B square. And in our specific expression a equals to a and b equals to square root of 3. So a minus b squared will be equal to a minus square root of 3 squared, that equals to 0. We took a root out of this equation and we got that a minus square root of 3 equals to 0. We added square root of 3 to this equation and we found out that a equals to square root of 3 units. So here we can write down that a equals to square root of 3 units. Here also a equals to square root of 3 units. And there also a equals to square root of 3 units. And then we focused on triangle DEB. We implemented the Pythagoras theorem and this triangle, the right triangle, triangle DEB. According to the Pythagoras theorem, DE squared plus EB squared equals to DB squared. DE equals to square root of 3. So DE squared is square root of 3 squared. Square root of 3 squared is 3. EB squared is EB squared. DB equals to 2. So DB squared is 2 squared. 2 squared is 4. Here we subtracted 3 from this equation, equation number 1. And we got that EB squared equals to 4 minus 3 is 1. Here we took a root out of this equation, equation number 1. And we got that EB equals to square root of 1. Square root of 1 is 1. So we found out that EB equals to 1. And because of the fact that the opposite sides of a rectangle are equal to each other, DF also will be equal to 1. And what is the value of AE? AE equals to AB minus BE. AE equals to AB minus BE. AB equals to 4. BE equals to 1. So AE will be equal to 4 minus 1. That is to say AE equals to 3 units. Now it is very easy to find out the area of quadrilateral ABCD. The area of quadrilateral ABCD equals to the area of the right triangle ADE plus the area of rectangle DFEB plus the area of the right triangle DFC. The area of the right triangle, triangle ADE, it equals to the base of the triangle, that is AE, times the height, that is DE, over 2. The area of rectangle DFEB equals to the width of the triangle, that is AEB, times the length of the triangle, that is FB. So it is actually EB times FB. And the area of the right triangle, triangle DFC equals to the base, that is DF, times FC over 2. So AE is 3, DE is equal to 3. Therefore the area of the right triangle, triangle ADE is equal to 3 times 3 over 2. And the area of rectangle EBDF is actually square root of 3. And the area of the right triangle, triangle DCF equals to DF, that is 1, times CF, that is square root of 3 over 2. Here we multiply square root of 3 by 2 and we divided it by 2 in order to have a common factor with the under 2 expressions. And then we took square root of 3 over 2 as a common factor. Inside the brackets from this expression is left 3, from this expression we have 2, and from this expression we have 1. In conclusion, the area of quadrilateral ABCD equals to square root of 3 over 2. 3 plus 2 is 5, 5 plus 1 is 6, and 6 over 2 is 3. So in conclusion, the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. So we finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD using the second method. In the second method, we did another construction. Actually, we from point A, we draw perpendicular to AB, so this angle is 90 degrees. And from point C, we draw perpendicular to CB, so this angle is 90 degrees. And we define the intersection point between the perpendicular from C and the perpendicular from A as point E. So we created quadrilateral ABCE. In quadrilateral ABCE, we have 3 right angles, 1, 2, 3. And This angle, we define this angle x, and we know that the sum of the angles in any quadrilateral is equal to 360 degrees according to rule number 1. So in quadrilateral ABCE, the sum of the angles must be equal to 360 degrees, that is to say 270 degrees plus angle x must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation and we got that angle x equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle x is a right angle. So in quadrilateral DF ABCE we have 4 right angles, and according to rule number 2, quadrilateral DFEB that has 4 right angles must be a rectangle. And then we know that the opposite sides of a rectangle are equal to each other, that is to say AB equals to CE according to rule number 4, according to rule number 3. But it is given us the equation that AB equals to 4. From this equation we will conclude that CE also equals to 4 units. CE equals to 4 units. Then we know that here likewise according to rule number 3 AE equals to CB. The opposite sides are equal to each other, so A equals to CB, and if we define CB as x, then from this equation we will conclude that AE also equals to x. But it is given us the question that CB equals to AD, and CB equals to x according to our definition. So from this equation we will derive that AD also equals to x. Here AD also equals to x. Then what is the value of this angle? The value of this angle is 90 degrees minus 40 degrees, that is to say this angle equals to 60 degrees. So I copied triangle AED in a new page and we analyze triangle AD. This is triangle AED. This angle equals to 60 degrees, and we know that those two sides are equal to each other. And in front of equal sides in the triangle there are equal angles. That is to say those two angles must be equal to each other. So if this angle is y, this angle must be also equal to y. And the sum of the angles in any triangle equals to 180 degrees. That is to say y plus 60 degrees must be equal to 180 degrees. Y plus y is 2y. 2y plus 60 degrees equals to 180 degrees. Here we subtracted 60 degrees from this equation and we got that 2y equals to 120 degrees. We divided this equation by 2 and we got that angle y equals to 60 degrees. So this angle is 60 degrees and this angle is 60 degrees. Therefore triangle AED is an equilateral triangle. That is to say ED also will be equal to x. Here we can write down that ED equals to x. This angle is 60 degrees and this angle is 60 degrees. But if this angle is 60 degrees and angle AEC is 90 degrees, this angle must be equal to 90 degrees minus 60 degrees. That is to say, this angle must be equal to 30 degrees. Again, angle AEC is 90 degrees minus this angle that is 60 degrees is the side of this angle, because if you take this angle and subtract from it this angle, you will get this angle. That is to say 90 degrees minus 60 degrees equals to 30 degrees. So this angle is 30 degrees. Then we prove that those two triangles can go into each other. Why those two triangles can go into each other? First of all, we know that AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. Those two angles, they are equal to each other. They are both equal to 30 degrees. Angle DAB equals to angle DC equals to 30 degrees. And also ED equals to AD equals to X. So actually prove that the triangle ADB can go into triangle DC according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that CD equals to DB. CD equals to DB. But it is given us the question that CD equals to 2 units. From this equation we will derive that DB also equals to 2 units. Then I copied triangle ADB in a new page and we implemented the actually here I copied triangle ADB in a new page and we implemented the law of cosines in this triangle, triangle ADB. This is triangle ADB, and we implemented the law of cosines on this triangle, triangle ADB. According to the law of cosines, cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. Cosine 30 degrees is equal to 3 over 2. X squared plus 4 squared is 16 minus 2 squared is minus 4. 16 minus 4 is 12. 2 times 4 is 8. 8 times x is 8x. Here we multiplied this equation by 8x. We got this expression. 8 over 2 is 4. So in this side of the equation we have 4 times square root of 3x equals to x squared plus 12. Here we subtracted 4 times square root of 3x from this equation and we got that x squared plus 12 minus 4 times square root of 3x equals to 0. Here we substituted 12 by 2 times square root of 3 squared and we got that x squared plus 2 times square root of 3 squared minus 2 times x times 2 times square root of 3 equals to 0. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3. So according to this algebraic identity, we can substitute this expression by a minus b squared that equals to 0. In our specific expression, a minus b squared, it is actually a is x and b is 2 times square root of 3. So a minus x squared, it is actually x minus 2 times square root of 3 squared that equals to 0. Here we took out of this expression and we got that x minus 2 times square root of 3 equals to 0. We added 2 times square root of 3 to this equation and we found out that again x equals to 2 times square root of 3 units. So here we can write down that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units. Here x equals to 2 times square root of 3 units. And here also x equals to 2 times square root of 3 units. Now, in order to calculate the area of triangle ADB, we drew perpendicular to AB. We define the touching point between the perpendicular and AB as S, and we define ds as h. Here we know that sinus 30 degrees equals to h over 2 times square root of 3. In triangle ADB, sinus 30 degrees equals to h over 2 times square root of 3. Sinus 30 degrees is 1 over 2, so 1 over 2 equals to h over 2 times square root of 3. We multiplied this equation by 2 times square root of 3, and we found out that h equals to 2 times square root of 3 over 2. 2 over 2 is 1. So we found out that h equals to square root of 3 units. Here h equals to square root of 3 units. Now it is very easy to find out the area of triangle ADB, because the area of triangle ADB equals to the base of the triangle that is AB times the height that is h over 2. AB is 4, h is square root of 3 over 2. 4 over 2 is 2. So we found out that the area of triangle ADB equals to 2 times square root of 3 square units. Then the only thing that is left to find was to find out the area of triangle EDC. In order to find out the area of triangle EDC, we actually calculated the semi-perimeter of triangle EDC. The semi-perimeter of any triangle is the perimeter over 2. Here A equals to 2. A equals to 2. It is here. But, we have to find out the area of triangle DBC, because the area of triangle DBC plus the area of triangle ADB equals to the area that we are looking for, that is the area of quadrilateral ABCD. So here we want to find out the semi-perimeter of this triangle DBC. Here A equals to 2 units, B A equals to 2 units, B equals to 2 units, and C equals to 2 times square root of 3 units. Here A equals to B, A equals to 2, B equals to 2, and C equals to 2 times square root of 3 units. And the semi-perimeter of triangle DBC equals to the perimeter over 2. And the perimeter is 2 plus 2 plus 2 times square root of 3. And if we divide it by 2, we will get the semi-perimeter. 2 plus 2 is 4. 4 plus 2 times square root of 3 over 2 is the semi-perimeter. So 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle DBC is 2 plus square root of 3 units. A equals to 2, B equals to 2, and C equals to square root of 3 units. And the area of triangle DBC was calculated according to this formula, that the area equals to the square root of S times S minus A times S minus B times S minus C, when S is the semi-perimeter of the triangle. That is actually 2 plus square root of 3 units. A equals to 2, B equals to 2, and C equals to 2 times square root of 3 units. So here S is 2 plus square root of 3 units. S minus A, it is actually square root of 3, S minus B is square root of 3, and S minus C is 2 minus square root of 3 units. So square root of 3 times square root of 3 is 3, and 2 plus square root of 3 times 2 minus square root of 3, it is actually 4 minus 3. 4 minus 3 is 1. So the area of triangle DBC equals to square root of 3 square units, and the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DBC. The area of triangle ADB is 2 times square root of 3 units. The area of triangle DBC is 1 times square root of 3 units. 2 times square root of 3 units plus 1 times square root of 3 units is 3 times square root of 3 units. So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. In both methods, that is the result. Okay, thank you very much.